Welcome to Science to Sleep By. Tonight, we drift not just through space, but through mystery. A small traveler from the depths of interstellar space named 3 Atlas may have carried with it the story of another star system. But as it passed through our neighborhood, something remarkable happened. Astrophysicist Avi Loeb believes it broke apart, shattered into 16 glittering fragments, like a celestial message written in light. So, as you lie back and close your eyes, let's explore how science meets wonder, how fragments tell stories, and how curiosity never sleeps. This is Science to Sleep By, and tonight, we unravel the mystery of 3 Atlas, the interstellar visitor that split into 16 pieces. In the vast silence between stars, where light takes years to cross from one point to another, the universe occasionally sends a traveler, an object so rare, so fleeting, that it humbles even our most advanced instruments. The story of 3 Atlas begins not with a bang, but with a whisper. It was discovered quietly, in early 2020, by the Atlas Survey, the Asteroid Terrestrial Impact Last Alert System, a network of telescopes in Hawaii designed to detect near-Earth objects before they strike. But what it found that year was not something born of our solar system. This visitor was an outsider, an interstellar nomad passing through the warmth of our sun's gravity for, perhaps the first and only time. 3 Atlas carries a name that encodes its identity, the 3 meaning. It is the third interstellar object ever detected, following 1 Oumuamua in 2017 and 2 Borisov in 2019. That numbering hides the enormous magnitude of what such a discovery represents. To detect a single interstellar object in our cosmic lifetime is astonishing. To have 3 within just a few years reshapes how we think about the space between stars. It tells us that the galaxy is not empty, but instead filled with wanderers, fragments, perhaps, of shattered worlds. Frozen relics drifting in interstellar cold until gravity pulls them toward new suns. When 3 Atlas was first seen, astronomers noted something curious. Its path through the sky followed a hyperbolic trajectory, a telltale sign that it was not gravitationally bound to our sun. It was simply passing through, moving too fast to ever return. That alone was enough to mark it as extraordinary. But what made it even more fascinating was its light. Observations showed that it was unusually bright for its size. Its coma, the cloud of gas and dust surrounding it, expanding dramatically as it neared the sun. To some, it looked like a typical comet that had traveled for eons between stars. To others, it was behaving too erratically, almost like it was unraveling from within. This is where the imagination of scientists begins to stretch, where the boundary between curiosity and discovery blurs. The idea that something could travel across the gulf between star systems, through radiation and cold and darkness, and arrive intact, is almost miraculous. Every interstellar object carries within it the chemistry of another world. The minerals, the ices, the molecular fingerprints of a distant sun. 3 Atlas might have been born in the outskirts of a completely different planetary system, ejected long ago by the gravity of some massive planet or stellar event. It could have wandered for billions of years, untouched, until it met the faint pull of our sun and came spiraling into our view. For astronomers, the arrival of an object like 3 Atlas is a cosmic lottery. It offers a rare chance to study what lies beyond the solar bubble, not through telescopes peering outward, but through material that has come to us. Every observation becomes a dialogue with the unknown. What is its composition? What kind of star once warmed it? Did it come from a system with planets, or from a dying sun shedding its outer layers? In those questions lies the deeper human desire, not just to see the universe, but to understand our place within it. Unlike Oumuamua, which sparked debates over its possible artificial nature, 3 Atlas seemed at first to fit more comfortably within the boundaries of natural phenomena. It displayed the outgassing typical of comets, jets of vaporized ice and dust as it approached the sun. Yet, as data accumulated, astronomers noticed inconsistencies. The rate of its brightening and its subsequent dimming did not match the predictable patterns of a normal comet. Its nucleus appeared unstable, possibly breaking apart long before it reached its closest approach to the sun. This raised an intriguing possibility that 3I Atlas was already fragmenting, perhaps due to internal stress or an inherent fragility from its long interstellar journey. Imagine, then, a frozen traveler that has spent millions, perhaps billions, of years, moving through absolute zero, enduring radiation, cosmic dust, impacts, and gravitational tides from distant stars. Over such immense timescales, internal fissures could develop, microscopic cracks that weaken its core. When it finally approaches a warm star like ours, the temperature difference becomes catastrophic. The ices inside expand, gases sublimate, and the internal pressure grows until the structure can no longer hold. What follows is a quiet explosion of breakup that scatters fragments across space like glittering shards of glass drifting in sunlight. From the perspective of an observer on Earth, these events are almost poetic. Through telescopes, we watch as brightness curves fluctuate, as tails lengthen and then dissolve. In those delicate changes of light, astronomers read the story of disintegration, the moment when an ancient visitor surrenders to the forces that have always ruled the cosmos. For scientists like Avi Loeb, such moments are not endings, but revelations. Every fragment, every shift in brightness, tells us something about the material strength, composition, and origin of the object. 3I Atlas, in that sense, becomes both a messenger and a mystery, a symbol of how fragile even the grandest travelers can be. In the broader landscape of astronomy, interstellar visitors like 3I Atlas are rewriting the textbooks. They remind us that our solar system is not isolated, but part of a galactic traffic flow of material constantly exchanged between stars. The dust that forms planets, the ice that carries organic molecules, and the fragments of comets like 3I Atlas all weave together into the grand tapestry of cosmic evolution. Somewhere in that vast interstellar ocean, another world may be watching one of our own fragments passing through their skies. A mirror of this moment, seen from another sun. And as the night deepens, the thought lingers. The universe does not send us these travelers often, but when it does, they carry stories older than our species, older even than our sun. The arrival of 3I Atlas was one such whisper, a faint reminder that beyond the boundaries of our solar home, an infinity of other worlds exists, each one with its own fragments waiting to be found. When Harvard astrophysicist Avi Loeb turned his attention toward 3I Atlas, it was not just another cosmic discovery. To him, it was a clue. A whisper from the deep galactic night that begged to be interpreted differently. Loeb has long been known for pushing the boundaries of how we think about interstellar visitors. He is a man who dares to look beyond conventional explanations, one who sees possibility where others see coincidence. When he examined the data on 3I Atlas, he did not just see a comet breaking apart. He saw the potential trace of something extraordinary. To him, 3I Atlas might not have been an ordinary object at all. It might have been something that fractured in a way that reflected a deeper story, one that could change how we understand the cosmos itself. The official observation suggested that 3I Atlas was fading faster than expected, breaking apart as it neared the sun. Most astronomers considered this behavior typical of a fragile comet. But Loeb noticed that the details didn't fit so neatly into the standard narrative. The light curves, the timing of the disintegration, and the distribution of fragments all hinted at a process that was not simply thermal destruction. Based on analyses of the available data, Loeb proposed that 3I Atlas did not merely fragment randomly, it seemed to have broken into 16 distinct pieces, each following a specific trajectory, almost like a controlled pattern of separation. This was not just a crumbling rock melting under sunlight. It was a deliberate fracture, a structured event that carried scientific weight and philosophical wonder. Avi Loeb's interpretation stemmed from his broader conviction that the universe may be filled with technological relics, not all of them natural. His views, often controversial, invite scientists to keep their minds open to the possibility that interstellar visitors, like 1I Oumuamua and 3I Atlas could, in some cases, be artificial remnants of advanced civilizations, probes, or defunct devices drifting through the void long after their creators were gone. In his eyes, the unusual breakup of 3I Atlas could be more than just a thermal event. It could represent evidence of a material structure or internal design that differed from ordinary comets. The figure of 16 fragments fascinated Loeb because it suggested precision. Nature is rarely so tidy in chaos. When natural comets disintegrate, their pieces are uneven, their debris clouds diffuse and unpredictable. Yet the data from 3I Atlas hinted at uniformity, as though the breakup occurred along structural lines or through sections that had similar composition and strength. That observation, while tentative, opened the door to questions that lie at the heart of Loeb's scientific philosophy. How do we distinguish between the natural and the artificial in the cosmos? And are we ready to accept the possibility that we have already encountered signs of alien technology? The idea of interstellar fragments behaving in unnatural ways was not new to Loeb. After all, his analysis of Oumuamua led him to argue that its acceleration could not be fully explained by cometary outgassing. Instead, he proposed it might be a piece of thin, reflective material, possibly a light sail, a relic of technological origin. When 3I Atlas appeared to break into 16 fragments, it resonated with that earlier line of thinking. The pattern of disintegration could hint at an internal structure that was engineered, or at least not entirely random. Even if it was natural, Loeb argued, understanding its fragmentation would still reveal something profoundly new about the materials that form beyond our solar system. His hypothesis, while provocative, was built on observable physics. Loeb and his colleagues analyzed the energy distribution, the timing of the breakup, and the brightness of each fragment. What they found suggested that the object began breaking apart at a distance too far from the sun for heat alone to explain it. This implied that internal forces, possibly mechanical or structural, played a larger role than previously assumed. Some materials, when subjected to stress, fracture in geometric ways, like glass shattering along tension lines. Loeb wondered whether the same could be true for an interstellar object composed of exotic compounds or manufactured alloys. In interviews and essays, Loeb often returns to the same fundamental point. Science progresses when we are willing to question our assumptions. For centuries, humanity believed that all celestial bodies revolved around Earth, until observations proved otherwise. The discovery of interstellar objects in our time demands the same humility. If something behaves unlike anything else we've seen, we should not rush to label it as familiar. We should investigate it deeply, even if that means confronting ideas that feel uncomfortable. Loeb's interpretation of 3I Atlas as having broken into 16 pieces is not just about the object itself. It is about cultivating a mindset of curiosity unbounded by orthodoxy. The astronomical community remains divided about Loeb's ideas. Many scientists view them as speculative, pointing out that data on 3I Atlas is limited and that cometary fragmentation can often appear deceptively structured when viewed from afar. Yet even critics acknowledge that his questions are valuable. They challenge researchers to refine their models, to gather more data, and to prepare for the next interstellar object that crosses our path. Loeb's hypothesis becomes a catalyst whether one agrees with it or not. It pushes the field forward by forcing scientists to look harder, think deeper, and explore beyond comfort zones. To understand why Loeb's voice resonates so strongly, one must see the deeper philosophical layer of his approach. He treats every celestial event as a possible message, not in the mystical sense, but as a signal that the universe is speaking through its physics, inviting us to decode its patterns. In the case of 3I Atlas, the act of breaking into 16 fragments becomes symbolic, a moment where a cosmic traveler reveals its inner truth, one piece at a time. Each fragment becomes a page torn from an ancient book of galactic history, scattered into the dark for us to read through telescopic light. This vision, equal parts poetic and scientific, bridges to worlds, the cold precision of data, and the warm pulse of human wonder. Loeb's hypothesis does not demand belief, only attention. It reminds us that science is not just about confirming what we already know, but about remaining open to what we might have missed. In the faint light of 3I Atlas, disappearing into the depths of space, He saw a story of transformation from wholeness to fragmentation, from certainty to curiosity, from silence to discovery. Whether natural or something more, the idea that it broke into 16 pieces will linger in the minds of those who study the stars. A reminder that sometimes the universe reveals its secrets not through what survives, but through what breaks apart. The breaking of 3 Atlas was not a single explosion or a dramatic flare in the dark sky. It was a slow, delicate unraveling, a quiet catastrophe unfolding light years from where it was born. Astronomers who tracked the object through the spring of 2020 saw its brightness fluctuate in ways that spoke of internal chaos. Its once stable glow began to flicker and fade, as if its heart was splintering. The comet's nucleus, which had held together across unimaginable stretches of time and distance, suddenly lost its cohesion. What followed was an elegant kind of disintegration, cosmic ballet of debris and dust, each fragment reflecting the faint sunlight as it drifted apart from its parent body. The physical forces behind that breakup are rooted in the same cosmic laws that sculpt stars and destroy them. When a fragile interstellar object like 3I Atlas enters the inner solar system, it faces an environment far harsher than anything it has known. For perhaps billions of years, it wandered through interstellar cold, a region so frigid that the frozen gases within it remained solid, locked in perfect stillness. Then, as it approached our sun, that stillness shattered. The heat began to seep in, awakening volatile compounds that had been dormant since the birth of its parent star. Inside its icy body, carbon monoxide, methane, ammonia, and water began to sublimate to turn directly from solid to gas. These expanding pockets of vapor built up pressure, searching for release through cracks that may have already formed during its long, lonely voyage. As the object drew closer to the sun, those forces intensified. Every rotation exposed different surfaces to sunlight, creating cycles of heating and cooling that caused stress to ripple through its structure. Tiny fissures widened. The nucleus, perhaps already weakened by micrometeorite impacts and cosmic radiation, began to lose its grip. Eventually, the internal tension exceeded the strength of the material that held it together. With a soundless burst, invisible to human ears, the comet fractured. 16 fragments drifted away, each taking its own path, yet bound by the memory of their shared origin. To understand the beauty of this destruction, one must imagine the mechanics of tidal stress, the gravitational stretching that occurs when a smaller body moves through the strong pull of a larger one. While the sun's tides may not have torn 3I Atlas apart by themselves, they amplified the stresses already at work inside it. Even a small difference in gravitational pull between its near side and far side could have deepened existing fractures. Combined with the violent jetting of gas as it heated, these forces created a perfect storm of instability. The moment of breakage, then, was not simply an accident. It was the inevitable conclusion of an ancient traveler's encounter with the star's unforgiving warmth. Astronomers watched the event unfold from observatories around the world. The Hubble Space Telescope captured images showing multiple bright points where once there had been one. Each point represented a fragment reflecting sunlight, a shard of the original nucleus. From Earth, these fragments looked like a trail of glowing embers left behind by a dying fire. The data showed that some of the pieces quickly faded, likely reduced to dust, while others lingered, drifting apart in the vacuum, their orbits slowly diverging. For scientists, every flicker of light, every spectral reading, was a clue. It revealed the composition, density, and fragility of the object that had come to us from beyond the stars. What made 3I Atlas particularly fascinating was that it began to fall apart at a much greater distance from the sun than most comets do. Typical solar system comets can survive far closer approaches before they disintegrate. This suggested that 3I Atlas was extraordinarily weak, perhaps held together only by the faint cohesion of dust and ice grains that had never been compacted by gravitational forces. Its life as an interstellar object may have left it brittle, eroded by cosmic rays and atomic collisions over millions of years. By the time it reached us, it was already a ghost, and the sun's gentle touch was enough to undo it completely. The breakup of 3I Atlas also raised intriguing questions about how interstellar objects are built. In our solar system, comets are products of formation near the outer edges of the sun's disk, where ice can survive. They are bound loosely, aggregates of frozen material and dust. But beyond our solar system, conditions may differ drastically. The interstellar medium is a harsh and varied place, where radiation and particle collisions can alter the chemistry of any exposed surface. Over eons, an object like 3I Atlas might accumulate layers of different materials, some dense, some porous, creating internal inconsistencies that eventually lead to structural collapse when heat is applied, for Avi Loeb and other astrophysicists. This moment of breakage was more than a simple physical event. It was a revelation. The way the object fractured, the number of fragments, their distribution, the velocity with which they separated, all carried encoded information about its internal structure. It was like watching an autopsy of a cosmic relic. Each piece, each trajectory, offered insight into what the original body had endured and how it had been assembled. To Loeb, the precision of the breakup pattern hinted that there was more to this story than ordinary cometary decay. It was almost as though the object had been designed to fragment in such a way, or that its composition followed an internal logic not yet understood. From a broader perspective, 3I Atlas's disintegration became a symbol of impermanence on a cosmic scale. Even something that had survived the emptiness between stars could not endure forever. The same forces that birth stars, planets, and galaxies also ensure their eventual destruction. The sun that illuminated its fragments was the same sun that pulled them apart. This cycle of creation and dissolution echoes through every level of the universe, from atoms splitting in fusion to galaxies colliding in slow, luminous spirals. For the astronomers who observed it, the moment of breakage was bittersweet. It marked the end of direct observation for an interstellar object that had promised new knowledge. But it also offered one of the most detailed glimpses yet into the fragility of such cosmic wanderers. Each broken piece scattered sunlight that had traveled across the same void it once had. Each shimmer was a fleeting signature of something both ancient and transient, an echo of forces too vast for human senses to fully grasp. In a way, the fragmentation of 3I Atlas was the universe's quiet performance, a reminder that even the smallest objects can carry the grandest stories, that beauty often lies in the act of breaking, and that the cosmos reveals itself most clearly when it begins to fall apart. When scientists first confirmed that 3I Atlas had come from beyond the boundaries of our solar system, it immediately entered a realm of questions that reached far beyond astronomy. What exactly was it? Was it a natural fragment of some distant planetary system, or was it something that defied our categories entirely? The discovery of any interstellar object challenges human understanding, but 3I Atlas arrived with a mystery layered deeper than distance. Its rapid disintegration, its unusual brightness patterns, and the complexity of its path raised doubts that it fit comfortably into the familiar mold of a comet. This was a moment where science and imagination collided, a place where observation gave way to interpretation, and interpretation opened the door to wonder. To call it an identity crisis was not poetic exaggeration. It was a genuine scientific dilemma. 3I Atlas behaved partly like a comet, partly like something else. When it was first detected, it displayed the hallmarks of cometary activity: a bright coma, a tail streaming away from the sun, and spectral signs of vaporizing ice. Yet its behavior over time was inconsistent. It brightened faster than models predicted, then dimmed unexpectedly, and ultimately broke apart long before it reached the sun's proximity, where most comets experience such catastrophic stress. Astronomers could not easily agree on what they were witnessing. It was as if the object were playing by rules from another cosmic manual, one written in the physics of another star system. Avi Loeb looked at that confusion not as a failure of understanding, but as an invitation. His perspective was shaped by years of studying anomalies, those rare events that refuse to fit neatly into our models. For Loeb, the ambiguity of 3I Atlas was precisely what made it significant. If it did not behave like a standard comet or asteroid, perhaps that was because it wasn't one. Perhaps it was something new, a different class of interstellar matter, or even a fragment of something once engineered. He had already made waves with his interpretation of one Oumuamua, suggesting that its acceleration and shape could indicate an artificial origin, possibly a piece of technology such as a solar sail. The controversy that followed did not dissuade him. It energized him. And when 3 Atlas entered the picture, Loeb once again urged the scientific community to look beyond conventional boundaries. His argument was not that every unusual interstellar object must be artificial, but that scientists must keep the question open until the evidence closes it. To him, the failure to consider extraordinary explanations when ordinary ones fail is a limitation of imagination, not of science. The fact that 3I Atlas disintegrated into 16 pieces added another layer of intrigue. Could a natural object really fracture in such a uniform and specific pattern? Could its composition or internal structure hint at something more complex than frozen rock and ice? Loeb's hypothesis was not born from fantasy, but from the recognition that the cosmos may contain more than one category of object: natural, artificial, and perhaps hybrids of the two, shaped by forces we have not yet identified. For centuries, astronomy has drawn a clear line between what is natural and what is made. Yet, in a universe 13.8 billion years old, that line may blur. Civilizations, if they have arisen elsewhere, might have left behind debris, technological fossils drifting in interstellar space long after their creators vanished. A derelict probe, a fragment of an ancient structure, or even a discarded light sail could, after eons, come to resemble a cometary body. Radiation, impacts, and dust accumulation could disguise its true nature, making it appear organic to our instruments. If such an object entered our solar system, how would we know? 3. Atlas forced scientists to confront that possibility, not as science fiction, but as a legitimate question of cosmic archaeology. This identity crisis, however, was not only about origin. It also challenged our assumptions about what defines an object's nature at all. In the solar system, we categorize comets by their tails, asteroids by their rockiness, and meteoroids by their size. But an interstellar visitor like 3I Atlas may not conform to those divisions. It was formed under the chemistry of another star, under a different balance of temperature, radiation, and pressure. Its internal materials could be compounds never found here, or arrangements of matter shaped by alien gravity and time. In that sense, even if entirely natural, it was still foreign in the most literal meaning of the word, an ambassador of alien geology, carrying in its molecular lattice the fingerprint of a different sun. The spectroscopic data gathered from 3I Atlas added to the confusion. Some observations suggested that its gas emissions were unlike typical comets, showing unusual ratios of carbon, oxygen, and hydrogen compounds. Others detected traces that could only be explained by the presence of complex organic molecules. These findings both thrilled and frustrated scientists, for they expanded the range of possibilities without offering a clear answer. If those compounds were natural, they hinted at rich chemical diversity among interstellar bodies. But if they were not, if the ratios were inconsistent with natural formation, then something else was at play. Perhaps the signature of processing or manufacturing on a scale we could scarcely imagine. For the general public, the idea of an interstellar object with an unknown identity ignited fascination. It evoked the same mix of curiosity and unease that accompanied Oumuamua. People wondered whether these objects might be messages or messengers, passing silently through our solar system, carrying with them the memory of civilizations beyond reach. Even among scientists, the conversation expanded from data to philosophy. What if the universe itself was filled not only with natural relics, but also with technological ruins? What if the cosmic silence we perceive is not absence, but distance, a gulf of time so vast that only debris remains? In this context, 3I Atlas became more than a comet. It became a mirror reflecting our own uncertainty. Humanity's search for understanding often leads to reflection on our own existence. We project meaning onto the unknown because we recognize in it our own fragility. Just as 3I Atlas broke apart under the strain of a star's heat, civilizations might break apart under the pressures of time and entropy. Loeb's curiosity about artificial origins was not simply about aliens. It was about legacy. What would our technology look like if it drifted through space for a billion years? Would another species mistake it for a natural object, as we may have done with this one? In scientific circles, debates continued long after Atlas vanished from view. Was it simply a comet too weak to survive its journey, or a messenger from a civilization long gone? The truth remains beyond our reach, locked within the fragments that now wander through the void. But the discussion it inspired changed the tone of interstellar research. No longer can we view such visitors as mere novelties. Each one carries potential evidence not only of chemistry and physics, but of history, intention, and perhaps even consciousness. The interstellar identity crisis of 3I Atlas is, in essence, a reflection of our own search for meaning amid the cosmos, a reminder that the boundaries between the natural and the extraordinary are not fixed, but forever in motion, just like the travelers who crossed between the stars when 3 Atlas shattered into 16 pieces. It was as if the universe had torn open a sealed letter and scattered its pages into the dark. Each fragment, drifting silently through the sunlight, became a messenger of cosmic memory, a shard of something ancient, carrying within it traces of another world's chemistry, another sun's light. To the naked eye, such a breakup might appear as mere destruction, a disintegration beyond recovery. Yet to the astronomers who studied it, this fragmentation was a revelation. It was as though the interstellar visitor had decided to reveal its secrets not in one form, but in 16. The number 16 itself took on symbolic weight among researchers and storytellers alike. For scientists, it represented a structured clue, an observable pattern that could be studied through telescopic data and brightness curves. For poets of the cosmos, it became an image, 16 pieces glinting like drops of molten starlight, cast across the void. To Avi Loeb, these fragments were more than the remnants of a disintegrated body. They were a dataset, a living archive of cosmic physics and interstellar history. Each piece followed a slightly different orbit, its velocity, angle, and brightness, carrying within it information about the moment of separation. From these trajectories, one could reconstruct not only how the object broke apart, but perhaps why. Every fragment was a capsule of information, a piece of frozen narrative waiting to be read by light. As the sun's radiation reflected off their surfaces, astronomers measured variations in luminosity that spoke of differences in size, composition, and density. Some fragments gleamed briefly before fading, likely reduced to dust or vapor under solar pressure. Others held together longer, drifting like tiny, steadfast survivors of a catastrophic voyage. Through those observations, scientists began to piece together a picture of what 3I Atlas had once been, a fragile structure, loosely bound, perhaps a conglomeration of ice and porous minerals formed in the outskirts of a distant star system, where heat was a rumor and cold was eternal. But Loeb's interpretation extended beyond simple structural analysis. He viewed the 16 fragments as individual storytellers, each holding a clue to the object's true nature. By examining how they separated, the uniformity of their distribution, the way they reflected light, he considered the possibility that the breakup had not been purely chaotic. It might have followed internal lines of weakness or pattern, suggesting that the interstellar traveler had an architecture of sorts. That idea straddled the line between the physical and the philosophical. Could a natural object, formed under alien conditions, possess a symmetry or intentionality that mimicked design? Or was this evidence of something more, a material once shaped by intelligence, now dissolving into cosmic anonymity? From a purely physical perspective, the 16 fragments offered a laboratory of interstellar chemistry. If each piece could be examined up close, scientists could test their isotopic ratios, study the distribution of carbon and silicate compounds, and trace the radiation damage accumulated over eons. These measurements would reveal where in the galaxy 3I Atlas might have originated. The hydrogen to deuterium ratio could point to the temperature of its birth cloud. while the oxygen isotope composition could identify whether its parent star was older or younger than the Sun. Each fragment, in that sense, was a frozen data log, a geological record of another planetary nursery, drifting through our cosmic neighborhood. But the true power of these 16 shards lay not only in their scientific value, but in what they represented to human imagination. They reminded us that the universe itself tells stories through destruction. Just as supernovae scatter the elements that later form planets and life, the breakup of 3I Atlas scattered fragments that could, in theory, seed new questions, new insights, even new discoveries. There is a strange poetry in that from breaking comes understanding, and from loss comes revelation. For billions of years, this interstellar traveler had moved through the galaxy intact, and seen, unheard, untouched by any civilization. Only in its final moments, as it fractured before our eyes, did it truly speak to us. For Loeb, the 16 fragments were the punctuation marks of that cosmic conversation. Each one symbolized a moment of transformation, from solid to dust, from mystery to measurable data. He saw in their pattern a message about fragility and endurance, about how even the most distant objects obey universal laws of physics, and yet still carry individuality. No two fragments were identical. Some were brighter, some dimmer, some more reflective, suggesting varying compositions. That diversity was not random. It was a reflection of how time and motion had sculpted the original body. The forces that broke it apart, solar heating, tidal stress, internal pressure, were also the sculptors of its identity. Astronomers tracked the fragments for as long as they could, mapping their paths across the sky. But interstellar time moves quickly, and light fades faster than understanding. Within months, 3I Atlas and its pieces became too faint to observe. They slipped back into the deep, leaving behind only their recorded light, spectral lines etched into data archives, the faint afterimage of a cosmic visitor that had already gone home. Yet those numbers and images are enough to inspire decades of study. The patterns of the breakup, the velocities of the shards, and the way each piece decayed hold the potential to refine our understanding of interstellar matter. Beyond the technical, there is something profoundly human in the way we interpret such events. We cannot help but see ourselves in them, in the way things fall apart, in the way light continues to shine even after breaking. The 16 shards of 3I Atlas are, like the pieces of memory, scattered but not lost, remnants of something that once was whole. In their drifting, they echo the journey of all matter in the universe, from stars to dust, from dust to life, and from life back to stars again. They are fragments of a larger cycle, each one an emblem of continuity through collapse. For those who watched the event unfold, it became clear that the story of 3I Atlas was not simply about an object breaking apart. It was about the universe revealing itself through the act of breaking. Every fragment was a metaphor, a tangible proof that in space, as in life, destruction and revelation are often the same thing. 16 pieces, 16 stories, all orbiting a shared truth, that even when something ends, it leaves behind traces luminous enough to guide others who look to the stars for meaning. The moment 3 Atlas split into 16 fragments, it didn't just disintegrate, it transformed into a case file for cosmic detectives. Each piece was a clue, each trajectory a trail, and each flicker of reflected sunlight a statement in an ongoing investigation into interstellar truth. To Avi Loeb and his colleagues, this wasn't the end of an interstellar visitor's story. It was the beginning of an intricate forensic analysis on a scale humanity had barely begun to grasp. What caused the object to break? What forces acted upon it across its vast journey? Was it heat, stress, or something altogether foreign, an influence not accounted for in our models of natural physics? To answer these questions, astronomers had to look beyond observation and into reconstruction, treating light, gravity, and dust as evidence in a universal crime scene. Cosmic forensics begins where direct contact is impossible. The fragments of 3I Atlas were millions of miles away, unreachable by any spacecraft. Yet every photon of light they reflected was a messenger, traveling across space to carry the fingerprints of the material it bounced from. Through spectroscopy, scientists decompose this light into its constituent wavelengths, searching for the spectral lines that betray the presence of elements like carbon, magnesium, silicon, and oxygen. Each dip or spike in the spectrum told them something about the object's composition, temperature, and structure. Loeb understood that these details were not just numbers, they were the signatures of cosmic history, the residual marks of an object that had formed under conditions our solar system had never known. When the breakup occurred, astronomers noticed that the fragments didn't disperse randomly. Their distribution suggested that the internal structure of 3I Atlas was uneven, with regions of greater and lesser cohesion. This was a key forensic insight in natural comets. Fragmentation often occurs when volatile ices buried beneath the surface begin to sublimate, turning from solid to gas, and creating internal pressure. If that process happens unevenly, the body can burst apart along its weak seams. Yet the pattern in 3I Atlas's breakup was strangely symmetric, its pieces radiating in a way that hinted at something more controlled. Loeb's interpretation invited curiosity. Was this uniformity a sign of a more deliberate, perhaps even engineered, composition? At the core of this investigation lay a paradox of evidence. To prove that something unusual had occurred, scientists needed data that no longer existed. The fragments had faded too quickly, vanishing into the glare of the sun and the vastness of space. But forensic science, even on Earth, often reconstructs past events from partial clues. Loeb applied that same logic to the cosmos. By studying the light curve of 3I Atlas before and after the breakup, researchers could deduce how its brightness changed over time, a method akin to reading a cosmic autopsy report. The rate of fading, the slope of its light curve, and the frequency of its flickers all corresponded to physical changes: surface area exposure, material vaporization, and dust production. Each of these phenomena left a measurable mark in the data, allowing the reconstruction of the object's last moments with surprising precision. A crucial part of this cosmic forensics was motion, the vector and velocity of the debris. After the breakup, each fragment traveled at a slightly different speed and direction, but not in a chaotic spray. Instead, their dispersal formed a gentle fan-shaped pattern, consistent with a low-energy fragmentation rather than an explosive one. This suggested that 3I Atlas did not collide with anything, but instead failed internally, perhaps due to cumulative heating or structural fatigue after centuries of interstellar travel. In forensic terms, it was not murder by impact, but death by exhaustion, a slow, inevitable weakening brought on by time, sunlight, and rotation. Loeb's team used orbital dynamics to calculate the energy distribution of the fragments, finding that their spread was too uniform for a random event. Something, perhaps the object's composition or internal geometry, had guided the breakup process. The dust cloud surrounding the fragments added another dimension to the investigation. Dust is often overlooked, but in cosmic forensics, it is as telling as blood spatter at a crime scene. The size and distribution of particles revealed the temperature thresholds the object had endured. Larger grains indicated a cooler, slower release, while smaller ones suggested rapid vaporization, a sudden flash of heat. When astronomers compared the dust signature of 3I Atlas to that of known solar system comets, they found inconsistencies. The interstellar object seemed to release less dust than expected for its level of brightness. This discrepancy pointed to a higher reflectivity, possibly due to metallic or exotic materials on its surface. If true, this was not a typical comet made of dirty ice. It was something stranger, denser, perhaps even manufactured. For Loeb, the forensic process was as much philosophical as scientific. He often reminded his audience that when you analyze cosmic debris, you are essentially reading the biography of an object through its ruins. The fracture lines, the velocities, and the spectral fingerprints are not just data, they are memories of stress, time, and travel. He compared the breakup of 3I Atlas to the cracking of an ancient artifact unearthed from the depths of the Earth, except this artifact had come from the depths of another solar system. Each measurement, each data point was a brushstroke in a larger painting of cosmic history. The task was not merely to identify what happened, but to understand why, to grasp the environmental and physical pressures that shaped this traveler's fate. There was also a temporal element to this forensics. The question of when the object fractured. Some data suggested that 3I Atlas began to weaken long before it reached the sun's intense heat, possibly as it approached from the outer solar system. That would mean the cause of its breakup wasn't solar radiation alone, but an intrinsic instability, perhaps rooted in its formation billions of years ago. If it contained internal cavities filled with volatile gases, then its journey through interstellar space might have gradually altered its pressure balance. By the time it entered the solar system, it was already primed to come apart. The sun's warmth would have been the final trigger, not the primary cause. In reconstructing that chain of events, astronomers also explored whether non-gravitational forces were at play. Some of the fragments accelerated slightly in ways that couldn't be explained by gravity alone. This kind of anomalous acceleration had also been noted in Oumuamua, another interstellar visitor that defied expectations. Could radiation pressure, outgassing, or something more exotic be responsible? Loeb's forensic lens invited open-minded speculation that perhaps these subtle accelerations were not the product of natural sublimation, but the decaying motion of something once structured, perhaps even technological. It was a bold idea, controversial yet scientifically framed, inviting the world to reconsider the boundaries between the natural and the possible. Ultimately, the cosmic forensics of 3I Atlas revealed more than just the story of a breakup. It illustrated the evolving sophistication of humanity's ability to read the universe. Where ancient astronomers saw wandering stars, modern scientists see evidence chains. Where once the night sky was myth, it is now a database. Every light curve, every spectral line a piece of testimony. 3I Atlas may have broken into 16 fragments, but in doing so, it multiplied its evidence 16-fold. Each shard became a witness, each orbit a statement, and each glint of light a whisper from across the cosmic abyss, in the silence of the cosmos. The breakup of 3I Atlas was more than a spectacle of celestial mechanics. It was a profound reminder of fragility, of how even the most ancient wanderers of space are bound by the same vulnerability that governs all matter. To Avi Loeb, this event became a kind of parable for cosmic existence, a reflection of how everything from stars to civilizations carries within it both endurance and impermanence. The 16 fragments of 3I Atlas were not just pieces of debris, they were symbols of the delicate balance that holds the universe together. A balance so fine that a whisper of heat, a flicker of light, or a trace of time could shatter it into luminous dust. When we gaze at interstellar objects like 3I Atlas, we are looking at survivors, ancient travelers that have journeyed for millions, perhaps billions, of years through the galactic void. They have withstood radiation, cosmic dust impacts, gravitational tides, and the slow corrosion of cosmic rays. To reach our solar system is, in itself, a triumph of endurance. Yet even such endurance has limits. 3I Atlas's disintegration demonstrated that no object, no matter how old or distant its origin, is immune to the relentless forces of the universe. As it approached the sun, the delicate equilibrium between its internal pressure and external stresses gave way. What followed was both inevitable and revelatory, a demonstration of the universe's quiet law. Everything changes, everything yields. This lesson in fragility extended beyond the realm of astrophysics. In studying the remains of 3I Atlas, Loeb saw a metaphor for the human condition, for our own place in the cosmic order. Just as the interstellar visitor held together through unimaginable distances, only to fracture when it neared the light, humanity too often finds that proximity to truth, energy, or revelation exposes its weaknesses. The heat that illuminates can also destroy. The same sunlight that revealed 3I Atlas's composition was the force that unraveled it. This paradox that discovery and destruction can be twins lies at the heart of cosmic fragility. From a scientific standpoint, 3I Atlas offered new understanding of how fragile interstellar matter can be. Many scientists had expected such objects to be dense, compact relics of distant planetary systems, hardened by their long journeys. Instead, 3I Atlas turned out to be fragile, porous, and low in density, more like a clump of loosely bound dust and ice than a solid rock. This changed the way astronomers thought about interstellar formation. It suggested that some planetary systems beyond our own produce comets and asteroids that are not solidified over time, but remain fragile aggregates, easily torn apart when subjected to heat or gravitational stress. Such fragility implies that the processes of planet formation and evolution are not uniform across the galaxy. Some systems may birth robust, metallic remnants. Others, delicate icy structures that can barely hold together across eons. The implications of this extend far. If 3I Atlas was fragile, then many interstellar objects that pass through our solar system may go unnoticed because they disintegrate before detection. This means the galaxy could be filled with the remnants of ancient systems, shattered fragments of failed planets, dissolved comets, and drifting dust clouds. Silent testimonies to the ephemeral nature of creation. Every time one of these objects crosses paths with our sun, we are reminded of how transient material stability is in the grand scheme of time. Even the stars themselves, those eternal points of light, are temporary structures, born from collapse and destined to fade. In that sense, 3I Atlas was not an exception, but an echo of the universal pattern: birth, endurance, disintegration, transformation. For Loeb, this recognition of fragility was not a source of despair, but of awe. The very fact that 3I Atlas survived long enough to be seen, to tell its story through light, was an extraordinary act of cosmic resilience. Fragility, he suggested, is not weakness. It is the condition of being alive in a universe that constantly changes. To be fragile is to be dynamic, to exist in tension with the forces that seek to dissolve you. The interstellar object's breakup was therefore a kind of final communication, a visual message written across the sky, saying that even in breaking apart, there is revelation. The data gathered from 3I Atlas's disintegration told scientists that the boundary between endurance and collapse is much narrower than previously assumed. The material makeup of the object, likely rich in volatile compounds such as carbon monoxide and methane ice, made it prone to internal heating. As sunlight penetrated its surface, these volatiles began to vaporize, generating internal pressure that exceeded the cohesive strength of the body. Like an overinflated balloon, it burst not in an explosion of violence, but in a slow, graceful unraveling. To watch that through telescopes was to witness the universe's version of aging, the gentle yielding of structure to entropy. And yet, through that yielding, it became luminous, more visible, more telling. In losing its shape, it gained its story. There is a certain humility that comes from studying such events. Astronomers spend lifetimes measuring light and predicting motion. But 3I Atlas reminded them that some things in the cosmos resist permanence, that the universe's beauty often resides in moments of impermanence. The 16 fragments, shimmering briefly before fading, embodied the truth that all forms of matter, no matter how enduring they seem, exist in cycles of transformation. Even the galaxies we see are temporary arrangements of stars, destined to merge, evolve, and dissolve into new forms. Fragility is not an anomaly in the cosmos, it is the rule. Reflections on this theme often turn poetic when addressing wider audiences. He would compare 3I Atlas's journey to a long pilgrimage through darkness, where the traveler carries within it the dust of creation, only to find that nearing the light demands surrender. The sun, in this analogy, is both a teacher and a test, a source of enlightenment that reveals what the traveler truly is. The object's breakup is not failure but revelation, an unveiling of internal truth. For humanity, he would say, the lesson is clear. To journey into the unknown is to risk being changed, even undone, by what we find. Knowledge itself is transformative, and transformation is never without loss. On a larger scale, the fragility of 3I Atlas mirrored the fragility of cosmic systems themselves. Stars die, galaxies collide, black holes evaporate, and the universe expands toward entropy. Yet within that vast decay lies creation. Every disintegration releases material for new beginnings. When 3I Atlas shattered, it may have released particles that will continue drifting for eons, perhaps to be incorporated one day into another planetary system, another comet, or even another being that looks to the stars and wonders where it came from. This endless recycling of matter, this conversion of fragility into continuity, is one of the universe's most profound truths. In studying the broken visitor, astronomers were reminded that even the most fragile phenomena can illuminate the greatest mysteries. 3I Atlas, in its brief and delicate passing, offered lessons that no intact object could have. It revealed the limits of endurance, the mechanisms of decay, and the quiet beauty of dissolution. In its breakup, it transformed from an interstellar stranger into a teacher, a being of light and dust, whispering through the void that everything, even in breaking, remains part of something eternal. The fragmentation of 3I Atlas into 16 pieces did more than provide a moment of cosmic spectacle. It opened a window into the broader implications of interstellar research and the evolving understanding of our place in the galaxy. Avi Loeb's analyses of the object challenged long-held assumptions about what interstellar bodies are, how they behave, and what they can teach humanity about the universe beyond our solar system. The breakup offered a rare and extraordinary opportunity to examine not only the physical properties of an alien object, but also the limits of human observation and interpretation, forcing scientists to rethink how they classify and study objects that arrive from the vast void beyond our sun. The first implication lies in the very nature of interstellar material. For decades, scientists assumed that objects traveling between stars would be relatively compact, dense, and resilient, hardened by eons of exposure to cosmic radiation and the harsh environment of deep space. Yet 3I Atlas demonstrated the opposite. An object composed of fragile materials, loosely bound, and extremely susceptible to the forces exerted by even moderate heating and tidal stresses. This fragility implies that interstellar objects may be far more diverse in composition and behavior than previously thought. It raises fundamental questions about the processes that create such bodies in distant planetary systems. Are they remnants of failed planets, loosely assembled comets, or byproducts of processes entirely unlike anything in our own solar system? Here was a visitor from the infinite unknown, wandering through our home before continuing into the void. It mirrored the universal human experience of transience. Just as 3I Atlas would never stay, we too move through the universe temporarily, leaving behind traces of existence before fading back into cosmic silence. The beauty of that truth resonated deeply. It reminded us that impermanence is not tragedy, but poetry, the essence of what makes us aware, conscious, and alive. Philosophers and cultural commentators began to frame 3I Atlas as an emblem of cosmic perspective. Carl Sagan once spoke of Earth as a pale blue dot, a fragile oasis in a vast dark sea. Now, decades later, 3I Atlas became a new symbol for that same humility. Its silent passage reminded us that the universe does not revolve around human drama. We are, in cosmic terms, brief and small. Yet in that smallness lies something extraordinary: awareness. We are the universe looking back at itself, capable of understanding what it sees. Every image of 3I Atlas carried that realization. It wasn't just a comet, it was a mirror through which the cosmos recognized its own consciousness, reflected in human curiosity. Psychologists studying public reactions noticed that discussions about 3I Atlas often turned inward. People began sharing reflections on existence, mortality, and meaning. The object became a kind of shared meditation, prompt for cosmic introspection. In the stillness of space, it invited questions that transcend time. Where did we come from? Why are we here? Are we alone? For generations, humanity has looked to the stars for answers. But perhaps the greatest answer lies in the act of looking itself. The awe we feel when confronted with the unknown is proof that we are part of something larger. That capacity for wonder is the bridge between the cold indifference of the cosmos and the warmth of human emotion. In a sense, 3I Atlas reminded us that discovery is not just about finding new things, it's about rediscovering ourselves. Each telescope image, each spectral reading, is a dialogue between humanity and the universe. When scientists decoded the light signatures reflected from its surface, they were reading a message written in the oldest language there is, light itself. And that light, traveling for billions of years before meeting our instruments, seemed to say that even across unimaginable distances, connection is possible. In studying 3I Atlas, we realize that knowledge is a form of intimacy. The very act of observation is an embrace across the stars. There's a quiet poetry in how our civilization responded to these images. Some saw them as reminders of our vulnerability, others as proof of our potential. In an age dominated by technology and distraction, 3I Atlas became a rare moment of collective stillness. For a few days, the world stopped scrolling and simply looked upward. People who had never before cared about astronomy found themselves drawn to its beauty. The object's delicate glow, captured against the backdrop of infinite night, rekindled something primal, a sense of belonging to the cosmos. It reminded everyone that we are not separate from the universe, but expressions of it. The same carbon, oxygen, and metals found in 3I Atlas flow through our blood and bones. We are, quite literally, made of the same cosmic material. As the final images of 3I Atlas settle into the archives of human discovery, they leave behind something far greater than data or documentation. They leave a feeling that the universe is both larger and more intimate than we ever dared to imagine. The official images released by NASA are not just glimpses of a cold, distant traveler. They are mirrors reflecting our own desire to explore, to understand, and to belong to something vast and timeless. In those swirling shadows of cosmic ice and dust, we see a reflection of ourselves, fragile, fleeting, yet endlessly curious. 3I Atlas, like the interstellar objects before it, reminds us that our solar system is not isolated, but connected to a greater galactic web, where fragments of other worlds drift silently through the darkness. These travelers are more than cosmic debris. They are messengers of history, carrying whispers of creation across the stars. They tell us that the boundaries we draw between here and there, between known and unknown, are illusions shaped by our limited view. The universe does not stop at the edge of our understanding. It continues, endlessly and beautifully, inviting us to follow. This is what makes the new official images of 3I Atlas so profoundly moving. They reveal not only the outer world, but the inner one, the landscape of the human spirit. Each pixel of that distant glow carries centuries of human longing, every calculation and photograph echoing the same question our ancestors once asked when they first looked at the stars: what else is out there? In that question lies the essence of who we are. We are a species built on curiosity, driven by wonder, and defined by the pursuit of the unknown. Science gives us the means to measure the cosmos, but imagination gives us the reason to look. Together, they form a kind of cosmic heartbeat, a rhythm that pushes us to keep reaching, even when the answers seem impossibly far away. The 3I Atlas images have reignited that rhythm. They have reminded us that every discovery is also an invitation, every mystery a door waiting to open. And though the object itself will fade into the endless dark, the light it left in human consciousness will not. We may never know where 3I Atlas truly came from or where it will go next, but that uncertainty is part of its beauty. It drifts, as we all do, across vast distances, guided by invisible forces, carrying stories too ancient to tell. Its brief visit was a reminder that even the smallest presence can reshape our understanding of everything. Somewhere in its icy heart may lie the ingredients of life, or the remnants of a forgotten system. Somewhere in its passing, humanity found itself once more in awe of creation's boundless scope. So tonight, as you drift into sleep under the same sky that once held 3I Atlas, remember that this moment in history is part of something greater, a cosmic conversation still unfolding. The universe speaks in silence, in light, in motion, and in mystery. And we, fragile yet determined, are learning to listen. The story of 3I Atlas will not end with its disappearance. It will live on in every dream, every telescope turned upward, every child who looks to the stars and dares to wonder what might be beyond. Because in the end, The greatest discovery is not out there among the galaxies, it's within us. It's the realization that we were always meant to look up, to search, to imagine, and to believe that somewhere beyond the stars, there's more waiting to be found.